So first of all, welcome to the session during the lunchtime, and hopefully I'm going to make sure you enjoy the material and the knowledge you're going to be learning from here. So today we're going to talk about how you can build a web API platform, use a whole bunch of open source solutions from scratch. And especially, we're going to build up this platform in Java because this is a Java 1 conference, and personally speaking, I'm a pretty big Java fan. Even though there are a lot of other solutions available today, like, for example, Node.js is pretty popular, and a whole bunch of Ruby on Rails guys too. But most of the concepts will apply no matter which programming language you choose to use. Right? And for this particular session, I'm going to try to share my real-world experience trying to hacking up an API platform to support my employer's requirements. And we actually leverage a lot of open source solutions. And hopefully, I'm going to give you some pointers to these open source solutions. When later on you try to do cherry picking, you can actually look at some of the candidates we have been evaluating, and hopefully that's going to give you a jump start to your own solution too. All right, a little bit about myself. I work for a company called Shopify. We are an online photo company which allows you to upload your photos and do a lot of physical gifts like greeting cards, photo books, iPhone case, all fancy stuff. Right? But I'm pretty much also an open source guy. I have been working on Apache Software Foundation for quite a bit, about 5-6 years for now. And I've been contributing to a few Apache open source projects, including Apache Tuscany, Wing, Ember. And I also wrote a book about the Tuscany SCA, which is a SOA framework which helps you to organize your business logic in a component-based approach and have the runtime to handle all the technical plumbings. So that's a framework we use as a backend to support service-oriented development approach. And we open up the service as a jack-sized resource. So that becomes the source of truth for the APIs. So I'm going to briefly go through a few things in this session. The first one, why we need to have an API platform, right? And I also try to bring you into the black box, look at some of the key components to enable your server as an API platform, right? And I'm going to leave a little bit of time for you to do some Q&A stuff. Feel free to interrupt me if you have questions in the middle. A little bit overview. So first of all, why do we need to have an API platform? So assuming a lot of companies these days are trying to build APIs so that we can extend the reach of the functionality provided by the company. It's not only just for third party, but also for internal consumption as well. In my opinion, maybe the very first step could be rationalize your system and open up your core functionality as an enterprise services and build nice API around that, because today most of the companies, they want to have mobile solutions, right? And you have native applications, and naturally all these functions all of a sudden becomes a requirement. You have to call into your system using an API, right? And strategy-wise, that gives you some buffer how you build up your API platform and incrementally open up your core functions as APIs. So you have the first set of alpha, beta customers from inside your company. They're going to give you a lot of feedbacks and make your app platform, make your API looks good before you open up to the third party for public consumption. So this talk, we're not going to talk about the philosophy, how you build a very nice API, how much REST is REST, but mostly focus on how we're going to build up some backend infrastructure. Most of the time, it's invisible and it's behind the scene, right, when you hit a particular API endpoint. But I'm not going to cover much about, what's a security model, what's the philosophy or religious belief for the API design and how you implement your, services as API. I try to group all the material following a thread. Say, okay, when third-party application come into your system, say from a web or from a mobile application, most of the time, the first thing they're going to do is make a whole bunch of REST API calls, right? So assuming we have an album, and the album can allow you to store pictures, right? So here's two sample APIs you might want to make a call. The first one is, okay, I'm going to try to get some information about all my albums. And second one is, I try to create an album for myself under this particular user ID. But later on, I'm going to tell you what's the magic behind this missing and what's this query parameter called access token. Right? So before I jump into all the details, I try to give you a big picture, like how this whole thing will potentially look like. So first of all, on the left side, you have all kinds of different client applications, right? So the client application, it's a term from oAuth 2, basically say whoever consumes your API, it becomes a client of your API. And the client could be an internal web application, could be a mobile application, can be a desktop application. Right? That doesn't matter. So in the center of the web platform, basically it's a whole kind of infrastructure try to deal with different concerns for the API invocations. For example, whenever an API comes in, you want to make sure we have enough authentication and authorization in place. We don't want to anybody from the planet try to use your function without knowing who they are and do they have permissions to do so. Especially if the data itself is owned by users, say if the user registered with your website and they have their own albums, right? So you need to keep the user, especially in the OAuth 2 term called resource owner, into the loop, right? And whenever API hit your API endpoint, so we have to do certain things to make sure there's no security concerns and the client application itself and the permission granted by the user is authorized. Then for some APIs, they might be do certain things in the middle, like do some mediations. If the client only support JSON and the backend only support XML, so you want to do XML JSON conversion, right? And also you want to track how many API calls are happening for this particular client application, so we need to track the usage of the APIs, and also from the performance perspective, say for this API, 90% of the time, the response time is within like a 30 millisecond. Right? Once you finish all this stuff, you need to hit the real API logic, basically some backend services to realize the function behind the API. Right? So because the API platform, logically speaking, there can be a separate box from the real services you are developing and providing the real business logic. So there's one network hub between your API server and some of the backend servers. Right? So the proxy, the HTTP proxy we use is kind of dispatch the request from your API endpoints to the corresponding backend protect resources or API logic. Right? So there's some trick you can play around the proxy because you can do routing, you can do versioning, and you can also potentially inject some context from the API request. So if we remember the sample API RESTful endpoint I gave to you, there's a special segment called me, right? So that me could be represent the logging user itself, and maybe your backend API then recognize me, they only recognize the user ID, right? So this is a perfect timing. We replace that me with real user ID because the user ID is known to the auth2 token. Right? And also we need to build up a whole bunch of infrastructure so that we can support the platform. So the bottom line, we showing some candidates. For example, we need to have some distributed data grid, some backed by NoSQL database, so we can register all the backend services and also keep track of the metrics information, the quota information, and we also allows you to do the client application registration and also keep track of the auth2 token so that we can know what permissions are being granted for a particular client application and how they're going to use it. And we definitely need to hook up with your existing security infrastructure. For example, you need to allow people to log into your system, use a user ID and a password, even though with the protection of auth2, that information will be captured by your system instead of the third-party system. But at the back, you still need to have some authenticate to handle that. And in a company with a lot of divisions, and if they don't have a single sign-on, potentially you need to support different realms and allow you log into the different subsystem in your company too. Right? So I sort of also went through this list of key components. It doesn't mean to be complete, but some ideas to run by. So we talk about the authorization and the authentication. So that's built on top of the auth2 specification. And we have a HTTP reverse proxy, which handles the API dispatching, some mediations, some monitoring framework, and you can do some analytics stuff, right? And definitely you need to have some backend infrastructure, for example, to manage the client registration and the auth2 token and manage all the publisher services. And also you need to do this matrix aggregation because you potentially have multiple instances of your API platform and you have physical endpoints coming before node balancer, but you want to aggregate all this information so that you can have a consistent view, like say for this third-party application within the NAS hour, how many calls does that application make, right? And to visualize that from the operational perspective or from the developer statistical perspective, you might want to provide some visualization. So you need to have a way to get your developers on board. Right? So first of all, most of the time, for example, if you go to Facebook, you need to register your client application and provide a whole bunch of information. Right? And as your application access and call the API, sometimes you want to have a snapshot, say, oh, what's going on, how many calls, what's the most popular API being hit by my system. And for developers, they probably need to have an easy way to discover how many APIs are available and what's the signature of the API look like. And even better, if you can just from within your browser start to play with some basic APIs. Right? And this slide gives you kind of sequential view when a particular API hit the endpoint, right? So HTTP requests coming in. We run through some role-based threat detection to make sure it's not a denial service or some invasions from hackers, right? Then after that, you need to check the auth2 token, see if this auth2 token is valid, and if it's valid, does that match the client claim of the client ID or the user permission? If yes, and we need to check against the resource that this API try to hit and make sure the token has the scopes which represent the set of permissions against the resources. And sure, we need to do some, metrics limiting stuff, and maybe to speed up the performance, we have some caching layer, and sometimes we do some mediation. And once we finish all this stuff, we figure out, okay, this API is meant to call a backend server. So then we do the routing and the proxying stuff. And you can hook with some analytics framework to give you a view like how your API behave, and what's the business opportunities behind that, right? And finally, it hits the API logic, which could be a JSON resource, which talk to database and produce JSON or XML representation of the response, right? So I'm going to spend some time look at OAuth 2.0. So maybe before I jump into the details, a quick poll, like how many of you are aware of OAuth 2.0 and how many of you actually are deploying the OAuth 2.0 as your server-side infrastructure? Because I know a lot of people using OAuth to talk to Facebook, talk to Twitter. Well, Twitter is not on OAuth 2.0 yet, but when you talk to other providers, OAuth 2 becomes the de facto standard, right? And my experience with OAuth 2.0 actually started with an open source project called Apache Ember. It's still under incubation, but the whole stack is pretty straightforward because, as you know, the OAuth 2 specification itself is pretty straightforward. But really, to make that available as a server-side solution, you still have to build quite a bit infrastructure to support that. And I sort of identify some SPIs, which becomes the integration point between the OAuth 2 framework or protocol against your metadata infrastructure or security infrastructure. A little bit overview of some of the OAuth 2 concepts. OAuth 2 try to define 4 different things. The first one is resource owner. Some people call that the user, right? That's the guy who actually owns the resource, and you try to protect against being violated, right? For example, if you create an album on Instagram, right, you are the guy actually own your album, right? Second one is the resource server. That's pretty much the backend resource endpoint to open up the RESTful resource or some other information. For example, if you go to Facebook, there's some server which gives you a list of your friends, right? And the third one is the most confusing term because when we talk about client, sometimes we talk about client server, but in the OAuth 2 term, the client really represents the consumer of the resource. So it's basically an application, right? And the OAuth 2 try to differentiate between a client and a resource owner, because when you try to make an API calls, potentially 2 identities are involved. One is which application is to make the call, and secondly, who's on behalf is the application work on. Because when you go to a third party and they say, I'm Raymond, right, but I'm trying to use a application from company XYZ, try to access my Facebook resources, right? The fourth one is the infrastructure for OAuth 2 called Authorization server. So that's the one responsible doing the authentication and authorization and try to build up the token as one level of interaction so that you don't expose your credential with your resource server directly to the third-party application. There's 4 different OAuth 2 flows support, and that can be used for different scenarios. So I just kind of list here for the completeness of the material. So the first one is authorization code. That's mostly for the server-side web application. The second one is implicit. That's based on the browser redirection and try to exchange the auth token and the credentials through the browser web page redirection. The third one and the fourth one, most of the time, either can be used by your internal components or used by a trusted third-party application, because that somehow involves a little bit sensitive information. For example, the resource owner password credential, which try to support a password based on authentication, and the password has the opportunity to be captured by the consumer side, the client side. And I try to map some of the flows into different use cases. So the first one, it's the trusted client. I mean, you really trust the client application, and that client application could be an internal application, could be a mobile client developed by your own company and released into the App Store. So there's two potential flow you can use. The first flow is a client credential for access token. And this one can be used for two different cases. One is for some resources which don't really have an owner. For example, you have a tax calculation service, right? And the tax calculation service is agnostic to the user, but you don't want to have everybody from the planet to use your tax calculation service, right? So you want to protect that resource with a client credential, which is a client ID/client secret. Right? The second one is if that resource also involve like a user login. For example, if you have a mobile application and you log in with your membership and you try to see all your albums, right? One flow you can use is this resource owner password flow. But for third-party applications, even though we can start from the internal consumers, but at the end of the day, you want to be able to open up your API to third parties so that your ecosystem will grow exponentially. Right? So oAuth 2.0 is designed for that purpose and works pretty well to support that kind of use cases. So we have two different flows to support that. The first one is the authorization code flow. Right? So that one, the difference is who actually gain the control of the security information. Both of flow don't expose the user ID and, well, at least don't expose the user password to the third-party application. But for the first flow, the server-side application gets the authorization code and exchange for the auth2 token. But for the fourth flow, the token goes directly back to the browser with HTTP fragment, and that fragment is now sending back to the server side. So only the user agent, the resource owner itself, can use that auth token from inside the JavaScript. Okay, so enough overview of auth2. So I guess what's more interesting is all the infrastructure plugin point. So definitely to support auth2, you need to have a concept of client application. You need to register certain information with your system, right? So for example, you have the name of your application and how are you going to do authentication with the backend. What's important here is for some of the flows, because we don't ask for the client secret, so this callback URI becomes pretty critical because when we make a redirection of the browser, we want to make sure the URI we are hitting, it's a safe URI, and we use this registration process to verify, to validate, to make sure that URI is a legitimate URI, right? So that's how auth2 use this scheme to guarantee the flow is secure. Second one, because you try to open up a whole bunch of resources, right? So the resource has to be protected. And typically you can partition your resource or classify your resource into a few different categories. One is, okay, it's a public resource. Anybody can hit it. I don't care. The second one is, okay, sure, it's not related to the resource owner. It doesn't really have an owner, but I still want to protect that resource. I only allow certain clients to access my resource. So that's the use case of tax calculation engine, right? So the third one is the most popular one. Basically, it's a resource which involves some user data. And we need to have a way to figure out, okay, based on the UI, can you tell who's the resource owner? So some REST API has a pattern to put the user ID as part of your endpoint. So that for that one, we can actually use the pattern match to figure out, okay, who owns the resource. And if not, then we need to have a little bit more involved logic. For example, some backend resource might have to do double check to make sure it's the right user ID hitting these protected resources. And also to have this concept of the scope.
So scope basically is an abstraction of permissions. For example, I have address book, I have albums, I have certain things with a particular company, right? So how you differentiate the different sensitivity of your information. For example, when you log into Facebook, the third party can get some basic information, but if you want to ask the email address, you need to have additional information, right? So that's being modeled as a scope in OAuth 2. And here's some JSON representation of these two set of metadata. Then we talk about the authentication and authorization, right? So we have to do certain things to make sure, first of all, the client is a registered client and it has a corresponding client ID and a client secret. And when we see an auth token or authorization code coming in, we need to do some database lookup or check into the signature to make sure the token, the code is valid. So there are a few different ways to do authentication. You can authenticate against the client application so that establish the identity for your client application. Then if you can do second level of authentication, basically you can authenticate against the resource owner using the user credentials, right? Then you have built up access control list. So when a particular request comes in, you make sure that identity has the right permission to come into your system. We have been talking about the token quite a bit, and the token basically is an opaque string being generated by the authorization server to represent the permissions. And it's also related to the identity being established for your client application and the user credentials, and also has the expiration date attached to that. Instead of directly asking for the user ID password, basically all the protected resources need to ask for the OAuth 2 access token, right? So the token encapsulates all the permissions the application has to access the resources. And in my experience, we decided to use MongoDB as a way to store the OAuth 2 token, because the usage pattern of OAuth 2 token is typically you request a token, that's going to be a write access, right? Once you write a record into your system for a period of time before the OAuth 2 token get expired, you actually, most of the time, doing lookup using the OAuth 2 token as the primary key, right? And the MongoDB actually works pretty well for these kind of use cases, and it also is pretty performed for read-heavy access. So so far so good. So here's some diagram which kind of glue all the different pieces we have been talking about together, right? So here's the typical OAuth 2 server-side infrastructure you might have to build up to support your system as the OAuth 2.0 provider, right? So we kind of list all the different pieces, and I try to group the different endpoints into the OAuth 2 concept. For example, if you look at the authorization server, we have two endpoints. One is the authorization endpoint, and the other one is a token endpoint, right? Then the resource server actually have kind of like a resource filter, look at the OAuth 2 token and make sure the token actually represent the right set of information. And if you look at the other boxes, basically that's the SPI implementations to deal with some of the metadata. For example, you have the client registration manager, which understand all the client registrations, and we have the authenticators, which understand the resource owner authentication. And we have the token manager, which understand all the authorization code and authorization tokens, right? And we have the resource access manager, which deal with the ACL stuff. And then behind the scenes, there are a whole bunch of database or store used to back all this infrastructure component, right? And finally, if everything is fine, then we go through this HTTP reverse proxy to hit the protected resources at the backend. So a little bit diagram about the scope. So we talk about the scope as a representation of permissions. So whenever OAuth 2 token comes in, it actually has a few attributes attached to it. So first of all, we understand which client application the token was generated before, right? And secondly, who's the resource owner behind the token. And then we have one or more scopes to decide, okay, if this token is allowed to access your friends list, if this token is allows you to see your email, right? So that's a scope concept. And for each of the protected resources, you can potentially say, okay, for this pass, we need to require one of the scopes. For example, you try to get an email, and then we probably need to have an email scope for that. To support all the different things, we have kind of UML diagram to show some of the attributes required to make this happen. Right? So the most critical one is the client registration and the OAuth token. So it gives you some basic idea, like when you try to mod up your OAuth backend, the metadata. Here's the things you probably have to look at it. And because we're talking about APIs, right? So who are you going to develop applications against APIs? So we need to have developers coming on board. And because API gives you a lot of things, and we need to have a way to manage the client resource, that kind of stuff. So we need to build up some UI to handle that. And potentially, we're going to provide a dashboard for developers, for your administrators, so that you can see what's going on, right? So you can actually monitor all the API usage by the client ID, by the resource owner ID, by the resource UIs, or by a timeline. And you probably need to allow the developers come into your system and say, okay, how many times my API is being called, and what's the average performance, what the permissions being graded, and how many token becomes expired, that kind of stuff, right? What's interesting is we find a pretty nice approach to handle the metadata itself. Basically, we open up the metadata itself as a whole bunch of REST APIs. So you can directly access this metadata or the usage through the APIs. So you can actually get a list of defined scope. So you can get some detailed information about a scope. You can also get a list of protected resources, what your URL pattern, and you can display what's behind a token that owned by you, right? So certain things like that. And we can actually apply the same infrastructure for this set of metadata APIs. Basically, we use the OAuth API to protect all these metadata API, especially for the sensitive information, right? A little bit performance information. So we use JMeter to develop a whole bunch of load testing, right? So the picture is a little bit small, but if you look at the numbers, most of them to get our token is under 10 millisecond kind of scope, right? And this was kind of measured against some development servers. So if we have higher-end server, it could be better. All right, so switch gear. Assuming we already have our OAuth infrastructure which can do all the authentication, authorization stuff, right? Now the API need to hit the real logic. So we need to have a proxy, a reverse proxy built into the API server, which understand how to do the routing, how to dispatch the HTTP request from the API server to the real server that hosts the resources, right? So one idea is don't try to mix these two types of traffic onto one server box, because for API server, most of the time, they just do authentication, authorization, and we need to have the throughput to handle the scale we need to support, right? And it's pretty much like I/O intensive, because we take the HTTP request and we kind of fan out to different backend servers. So we don't really do any logic, right? So we pretty much take the Apache HTTP components, especially the HTTP client, to build up this proxy. And actually, the code is pretty straightforward. It's not. It's probably only 3 or 4 pages of code. Right? But in the real deployment, we actually run into quite a few issues with this proxy stuff, especially from the connection management perspective, because we try to maintain a pool of persistent HTTP connections so that the API server can have pre-performed connection back to the backend service. But it turns out we have a few issues. For example, the keep alive, that's how long you're going to keep your persistent HTTP connection alive for reuse. It's really depends on the backend server. For example, if your backend server is a Tomcat server and you set up your keep alive for 30 seconds, that means if the connection becomes idle for 30 seconds, the server side is going to close that connection, right? So that means you cannot reuse that connection anymore. So one idea could be for the API server, you can have a different connector being configured for the Tomcat server, which try to support this nature of the persistency. But if the connection is for the public access, then you don't want to make the keep alive for too long. The second one is some engines backend, because that's another popular web server for PHP where some version of the Nginx server doesn't support the trunking mode. So when you dispatch the request from the internet to the backend, you might have to get the whole thing, build up the content names, then you shoot to the backend sometimes. The third one is it's pretty tricky sometimes when you try to get an HTTP connection, so you retrieve the information back from the response. For the HTTP client, one important API you need to remember is no matter if the response is a normal response or it's a for 500 response, make sure you consume the content. So that's how you notify the connection pool. You are done with the HTTP connection, then that connection can be released back to the pool, right? So I put a link here. So if you want to look at how you can make this super flexible and fit your requirements, you can take a look at that. So routing proxy, we actually just do a pretty straightforward routing. So we decided to adopt the JAX-size templating as a way to describe the routing table. So incoming requests with some path fragments, right? Then we dispatch to the backend, right? So this sort of explains like how we can potentially allows you to construct an API that's friendly to the logging user. For example, you put a me yourself, then because for each of the OAuth2 access token, we actually know which resource owner is behind that. So we can actually use that one to replace me so that the backend can see the user ID instead of hard-code the user ID in the system. So we also experiment a little bit like between event-driven proxy or just synchronous proxy. So I played a little bit with the Tomcat 6 with the Servernet 2.5 engine and using the Apache HTTP client directly. And I also use the Tomcat 7, which supports the 3.0. And I use the Apache HTTP asynchronous client, the beta 2. So here's a little bit code if you want to do the asynchronous fashion. But performance-wise, sure, we are seeing a little boost by the asynchronous invocation, but not so much. So it really depends on the nature of your API. So if it's very I/O intensive and you want to have the maximal throughput, you probably need to try async. But for most of the case, the synchronous invocation works pretty well. Even though I'm pretty much like Java, but Node.js is pretty attractive too. So we did some experiments, say, okay, what if we use Node.js as the platform for API server? Even though we like the event-driven model, but the result, at least from our testing, is not impressive. So we see Java goes well beyond the the benchmark we are seeing from the Node.js. Even a lot of people argue about that, but at least from my own testing for my use case, looks like Java is doing a much better job. Now I have a few more slides, kind of talk about some additional things. So one thing we have been talking about is the API tracking. So I found out a pretty good open source framework called, it's actually being open sourced by Yammer. It's written in Java, and it provides the base infrastructure to do the metric stuff. For example, it supports the counters, timers, and for timers, it supports like the standard deviation, maximal, minimal, 90th percentile, that kind of stuff, right? But what's even more interesting is support a whole bunch of reporters. Some reporters hook up with JMX. Some reporters talk to the Graphite API server, the visualization server, right? So that gives us a basic way to plug in the metrics mediation to support our systems. A few more slides because we talk about we need to have a way to get developers on board, right? And I find out a few interesting things around this area. So typically, we need to build up some APIs or tools, help the application developers to discover and explore the APIs, because when we start the portal with our internal consumers, the most common asked question is, okay, sure, you have this API. Can you give me like a sample, like a JSON input, output, what other headers should be set, and what's the expectations for the HTTP code, that kind of stuff, right? So we need to have something to serve that purpose. And especially we model the backend resource using JAX-RS, so it has a lot of interesting annotations which give us a picture how your API sort of looks like. So we study a few open source tools, and we kind of like the first one the best. It's called Swagger, and second one is from Google. That's a Google API Discovery. So I put a snapshot of the Swagger UI for your reference. So it gives you a list of all the APIs, and the first column using different color to represent, okay, if it's a get, a delete, or put, then the URL pattern, right? Then you can actually have some information, say what does this API do? And even more better is it gives you the sandbox, which allows you to fill in all this information. For example, this one try to get something by old ID, so you can actually type in old ID, so you can run the API directly from here, right? So it's pretty nice. And this framework actually have integration with a lot of common JAX-RS backend, so it can do a nice job to introspect and build up an API spec so that the UI can work against the spec. And the UI itself is written in HTML5 and decoupled from the backend annotation, so it works against the spec. So if you can come up with a spec from some other sources, this UI works pretty well too. And this set of open source framework also allows you to, based on the API spec, to generate the client code, support like all kinds of programming languages, Java, PHP, Ruby, Objective-C. So if you have this tool, it could be a quick starter for you. All right, so that's pretty much all for the material. So I'm going to leave maybe 1 or 2 minutes for questions.